Hey there. Hope everyone's hanging in there. Today in O-Level Chemistry, Lesson 9, Energy Changes and Reaction Profiles. Chemical reactions involve energy changes. Exothermic reactions release energy to surroundings, temperature often rises, combustion, neutralization. Endothermic reactions absorb energy, temperature falls, thermal decomposition of limestone, photosynthesis. Energy is conserved, total energy of system and surroundings is constant. Reaction profiles plot energy against progress of reaction. Activation energy EA is the minimum energy for successful collisions. Exothermic profiles show products lower than reactants, endothermic show products higher. A catalyst lowers EA by providing an alternative route but does not change overall energy change. Enthalpy change delta H is negative for exothermic and positive for endothermic reactions. Bond breaking is endothermic, bond making is exothermic. Delta H tilde sum of bond energies broken minus sum of bond energies made. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. If more energy is released forming bonds than used breaking them, the reaction is exothermic. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. Fuel cells and combustion release chemical energy as heat. Calorimetry measures temperature change when a known mass of water is heated by a reaction. Energy transferred Q equals mc delta T with C tilde 4.18 J over G deg C for water. Simple experiments compare fuels by temperature rise per gram burned. Everyday examples: hand warmers use exothermic crystallization, cold packs use endothermic dissolution. Photosynthesis stores solar energy endothermically. Industrial processes consider energy costs. The Haber process uses exothermic conditions favoring product at low temperature but needs high rate at moderate temperature. In exams, sketch profiles with axes labeled show EA with and without catalyst and state whether delta H is negative or positive. Link observable temperature change to energy flow direction. Distinguish activation energy from overall energy change. Industrial designers choose reaction conditions by weighing energy cost against product quality and safety. Exothermic reactions may require cooling to prevent overheating, whereas endothermic thermal decomposition needs continuous heating. Stating whether energy is absorbed from or released to the surroundings should accompany every reaction profile sketch in an exam answer. Hand warmers and self-heating cans use controlled exothermic reactions to release useful heat, while cold packs rely on endothermic dissolution. Being able to classify a named reaction as exothermic or endothermic from experimental temperature data is a core practical skill at O-level. When comparing fuels, the energy released per gram depends on bond energies in the products and reactants. Complete combustion of hydrocarbons is strongly exothermic because strong C equals O and OH bonds form in CO2 and H2O. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. Draw profile with reactants and products levels. Label EA and delta H, state exothermic or endothermic, and give one experimental observation. Burning methane is exothermic. Profile shows CH4 plus 2O2 higher than CO2 plus 2H2O, delta H negative, flame releases heat. Do not say catalyst changes delta H, or confuse activation energy with total energy change. Practice. Is neutralization typically exothermic or endothermic? Answer: exothermic. Temperature of mixture increases. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Sketch description. How does a catalyst appear on a reaction profile? Answer. Second curve from reactants to products with lower peak, smaller EA, same reactant and product energy levels. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Okay, that's it for energy changes and reaction profiles today. See you next time for continue the course. Take care, and I'll see you in the next one.